Welcome to Train Signal. This is the Configuring Networking in Windows 7 lesson in the Windows 7 Administration Training course. We'll start this lesson by going over our Global Mantic scenario to understand how networking fits in with Global Mantic's objectives. You'll learn how to manage network connections in Windows 7, and we'll quickly follow that with a recap of the ubiquitous TCP/IP protocol, including an operational and subnetting overview. You'll then gain some basic information about IPv6, although we won't cover it in depth in this lesson, but then we'll go over how to configure TCP/IP settings and network adapters in Windows 7. Then, we'll move on to configuring internet connection sharing, which is sort of a poor man's router that Global Mantic uses at some of its small regional offices and small branch offices. We'll finish up the lesson by talking about ways you can troubleshoot network connectivity using some of Windows 7's built-in tools. A computer not connected to a network is pretty useless these days. As such, every single device at Global Mantic is a business tool that has to be connected to the network. By the end of this lesson, you'll be able to provide Global Mantic with a lot of assistance in configuring the Windows 7 network settings for the pilot Windows 7 rollout. As a part of this lesson, Global Mantic wants to test the internet connection sharing tools that are built into Windows 7 to see if they can hold up and be used by smaller offices to replace the complicated networking equipment that already exists in those offices. Further, if the company is going to adopt Windows 7 as its corporate standard, the company wants to make sure that you, as the Windows 7 desktop administrator, can understand ways that you can correct potential networking issues. Therefore, you will learn about how to use some of Windows 7's built-in troubleshooting tools, particularly from the command line, that will help you in this endeavor. We'll kick this lesson off by learning how to connect a computer to a wired network. As you might imagine, connecting to a wired network from a physical perspective is pretty easy. One end of the network cable gets connected to the network adapter in the computer, and the other end gets connected to a wall jack, directly to a switch, to a router, whatever happens to be in the office. So it's very much like plugging a telephone into the wall or into some other device. It's very easy and really doesn't take a whole lot of time. As long as you hear a click, you're all set. And that click is the RJ45 connector, which is the name of the adapter at the end of the cable, plugging into the network adapter on the computer or into the wall. A click is good. Once you have that physical connection established, Windows 7 allows you to view your current network status and view a list of computers that network adapter can actually see. I'm going to move over to one of Global Mantic's systems right now so you can see this in action. This is a system that happens to be in the Global Mantic's network lab right now. It's not a production system because it's being used for testing Windows 7. If you look in the lower right-hand corner of the screen, you'll see the network icon, and if I hold my mouse over it, you'll see that there are two networks. One's connected to globalmantic.com, which has internet access, and the other one is called an unidentified network, and it has no internet access. If I just left-click that icon, I get the same information that doesn't go away. I can get a lot more information by clicking Open Network and Sharing Center link, the link that you see at the bottom of the window, and I'll do that now. Before I tell you about this screen, I want to tell you a couple of different ways you can get to the window you see. You can also right-click this icon and choose Open Network and Sharing Center. Or you can go to the Start menu, Control Panel, View Network Status and Tasks. Once you're at this window, you can see that there's a whole lot of information here. It gives you a network map. First of all, here's the GM7095 computer connected to multiple networks which are connected to the internet. There are two active networks on this computer. One called globalmantic.com, which is the domain network, and one unidentified network that's called a public network right now. The globalmantic.com network is accessible to the internet, so this machine can get up to the internet to get updates or browse the web or whatever you like to do. The adapter that's being used by this connection is named Local Area Connection 2. There are two network adapters in this system. The public network is connected to local area connection, which is just another network adapter. Now you can change the adapter settings or see a list of all the network adapters in your computer by clicking the Change Adapter Settings icon over at the left-hand side of the screen. And if you've used older versions of Windows, this screen should look very familiar. It gives you a list of the physical network adapters in your computer, and then from here you can make other changes to those network adapters. This is the network adapter being used by the domain system right now to communicate with the network. And you can see that they're both of the type Microsoft Virtual Bus Network Adapter. This is a virtual machine. If this was a physical machine, you would see the actual physical name of the network adapter, such as D-Link or Broadcom or what have you. To get more information about the connection, click the name of the adapter. And as you can see, this brings up the status of the local area connection to network adapter. And this tells me that as far as IPv4 goes, this is TCP/IP protocol version 4, the most common type of internet out there these days. It's connected to the internet. IPv6 is the up-and-coming replacement for IPv4. Both IPv4 and IPv6 are supported by Windows 7. However, IPv6 is not that common out on the internet yet, so there's no internet access via IPv6. The media state option here tells me whether or not I have a network adapter, a network cable plugged into the network adapter. The duration option tells me how long that network adapter has been connected. And the speed option tells me how fast this network adapter is. This happens to be a 10 gigabit per second network adapter, only because it's a virtual network adapter. Out in the real world, you're going to see mostly gigabit network adapters, or 1 gigabit per second is the speed. At the bottom of this window, you'll see that it tells me how much activity has taken place with this network adapter. I've sent about 1.5 million bytes of data out over this network adapter and received almost 3 million bytes worth of information. Clicking the Details button brings up additional information about this network connection, including a full description of the network adapter, its physical address, which is pretty key when it comes to troubleshooting. This is called the MAC address, or the Media Access Control address. This is the lowest level address that's assigned to a network adapter, and if you have issues with a Windows 7 machine, the network administrator at Global Mantex will probably ask you for this physical address. Is DHCP enabled, or Dynamic Host Configuration Protocol? You'll learn about DHCP later on, but for now just understand that this is a way that the machine automatically gets an IP address. If you don't use DHCP, you have to manually assign an IP address, and in this case it's 192.168.7.10. Here's the rest of the IPv4 addressing information, and a few other things that are not that important to go over right now. Understand that the link local IPv6 address is an auto-configured IPv6 address that's pretty common out on Windows 7 machines and Windows Server 2008 R2 machines. If you'd like to get a list of the other machines that are viewable by this computer, just click on the Multiple Networks link, and you'll get a list of the computers that this system can actually see. Right now, you can see that this system is capable of seeing a system named GM7095. Since that's this system, it's good that it can see itself. And this is all of the other systems that this machine is capable of seeing out on the network directly without additional assistance. Now, the reason it can't see more is other machines may have firewalls enabled or whatever, but for now, this is what this machine is capable of seeing. Managing wireless networks in Windows 7 has become really easy from a user perspective. In older versions of Windows, managing wireless networks could be a real pain. Every vendor decided that they wanted to implement their own wireless management utility. So if you got a network adapter from one company and a network adapter from another company, both of the wireless variety, and you tried to install them in two different computers, you may have a totally different user experience on each of those systems. So there was really no streamlined, common, easy way to manage wireless. Now, Microsoft worked hard to try to fix that issue, but a lot of vendors just didn't cooperate, and they insisted on using their own tools. Windows 7 has really simplified this process and made it very easy for organizations to use Windows 7's built-in wireless management tools. At the right-hand side of your screen, you can see a common Windows 7 dialog box that asks, which wireless network do you want to connect to? Now you can see that this system that the screenshot was taken from is already connected to a wireless network called the Lowe's. But there were two other wireless networks available that I could have connected to, one called Linksys G and one called 2Wire 798. Both of those are Neighbors Wireless that happens to be within range of the computer from which I took this screenshot. Now connecting to a wireless network is pretty easy. You choose the wireless connection, click Connect, and then if you're prompted, provide the wireless network password. I should tell you that most GlobalMantic's offices do have a wireless network, so this will be something that's used by your users out in the field at GlobalMantic's. The machines that I'm using that are connected to the Hyper-V virtual machines don't have wireless, but the recording machine I'm using does, so I'll be using that to demonstrate the wireless capabilities of Windows 7. I've chosen the Start menu, and you can see that I've got the network icon over here. I'm simply clicking the network icon to get to a list of available computers. And you can see that I'm currently connected to a wired network that has internet access, but there's a wireless network that's also available. If I hold my mouse over the name of the wireless network, I'll get some information about that wireless network, including the radio type, which is 802.11n, or the fastest wireless that's out there, the SSID, which is the name of the wireless network, and the signal strength and type of security that's being used. Simply clicking the name of the wireless network brings up a little bit more capability, including whether or not I want to connect automatically, which I don't, for this particular purpose, and then on the Connect button. When I click Connect, I'm going to be asked to provide the network security key. Now, if you want to make it more secure, you can hide the characters. So you type the network password and then click OK. If you've typed the password right, you'll be connected to that wireless network. And as you can see, once I'm connected to the wireless network, my icon changed to the one with all the little bars on it that you see in the screenshot up here. And now it'll show that I'm connected to the wireless network called the Lowe's. And when I expand that wireless network, I now have a disconnect option. Once you're connected to your wireless network, you can go to the Open Network and Sharing Center link at the bottom of the window, choose Manage Wireless Networks, and you can get a list of the wireless networks to which this computer has connected. As you can see, there's a network here called the Lowe's. There should be because I just connected to it with this system. Now, there's not a whole lot of interesting stuff here right now, but you can actually make some changes to the existing wireless network by right-clicking the network and choosing Properties. And as you can see, I have a list of properties here. If I want to connect automatically to this network whenever this computer is in range of the Lowe's wireless network, I can choose the box that says Connect Automatically when this network is in range. If I want to make this a secondary network, I can choose Connect to a more preferred network if available. Now, some organizations will do what they call hiding their SSID so that they're not broadcasting the name of their wireless network all over the place. You can choose the checkbox next to Connect even if the network is not broadcasting its name, and then this computer will still attempt to connect to this wireless network even if it can't really truly see it. On the Security tab, if the network password changes or you decide on a different type of security for your network, you can make those changes here. Advanced Settings enables some Federal Information Processing Standards compliance, which we will not be covering in this course, but I wanted you to see the screen. Now I'm going to add a fake wireless network from here. This gives you another way to add wireless networks. Perchance one of your people is going somewhere and you know that they're going to go to one of your offices, so you want to pre-configure the wireless network. So I click the Add button. I'm going to choose Manually Create a Network Profile. I'm going to call that GM-Southwest. That's going to be the GlobalMantic Southwest office. They're going to use WPA2 Personal, which is just it's called a pre-shared key type setup with an encryption type of AES, Advanced Encryption. The security key will be the password for the network. Now I'm going to choose not to start this connection automatically for now. That means the person will have to go there and actually proactively just choose connect when they get to the office. Now, as you can see, there's now 2 wireless networks here sitting on this screen. Well, that's okay, but suppose you want this one to be the one that's connected to first. Simply click Move Up, and this network then becomes the primary wireless network that if it's in range, the system will connect to it. Otherwise, if it finds the GMSW network, it will connect to it instead. Getting your computer actually talking on the network is only the first step of the networking process on any computer, and that's the case in Windows 7 as well. In order to communicate on the network, your computer has to have some kind of protocol by which to do so. That is the job of TCP/IP, which stands for Transmission Control Protocol Internet Protocol. We're going to go over a quick TCP/IP recap in this lesson. This is not going to be an in-depth analysis of how TCP/IP works, but it's intended to make sure you have just enough knowledge to be able to get by in Windows 7. Make sure you use other resources available from TrainSignal to get that in-depth TCP/IP knowledge that you will need in your IT career. There are a number of components that make TCP/IP work its magic. The first one is the network address, which is the address of the entire network as a whole. Next is the subnet mask. This provides bounds for the upper and lower ranges of the network address. So basically, once you have a network address and a subnet mask, you can then determine what your entire address scope is going to be. And you'll see this in action in just a few minutes. An IP address is an individual identifier assigned to a resource. For example, an IP address on your computer, an IP address on your iPhone, an IP address assigned to a printer. That's that individual unique identifier that's assigned to one of your resources so that it can communicate on the network. The default gateway is a special address that's the router or firewall port that connects the local network to a larger network. Most networks are broken down into pieces in order to make them manageable and so that they don't collapse under their own weight. In order for those systems that are on those mini networks to connect with the larger network and with the internet, they have to have some way to understand how to get out to those other networks, and that's the job of the default gateway. The router is the actual device. It's called a layer 3 device that's responsible for connecting that local network to a larger network and handling the incoming and outgoing network communications to and from the local network. Now, the reason I use the terminology layer 3 here is because there's actually an entire study around TCP/IP, and there's a model called the OSI model that's set up to tell you about all of the different layers of networking. Layer 3 is where routing happens, so that's where you have your routers and your firewalls sitting to a point. There are 2 primary kinds of IP addresses. There are public addresses, which you're going to use when you go out to something like Google or Yahoo or TrainSignal or GlobalMantics. And then there are private addresses. Now, the difference between the 2 is critical to understand. Public addresses are globally unique. No matter where you go, if you have a public address, there's one of those addresses in the entire world. Private addresses, on the other hand, are always used behind a firewall, and they can be used anywhere you want. If you look at these range of addresses, you're going to see them in use all over the place. Almost any router you buy from a place like Best Buy will use the 192.168 range for its addressing. And that's because anybody can use these addresses. Now, the way that IP works is if there's not a globally unique address, then IP doesn't know what to do. Basically, it says, okay, I give up. There's more than one of these addresses. I don't know how to get to the one I need because there's more than one. So you may be sitting here saying, well, if every router in the world that you buy from Best Buy uses 192.168, then how can this possibly work? How can these addresses possibly work on the internet? The short answer is that they don't work on the internet at all. In fact, if you go out to the internet, you'll never see one of these addresses. That's where network address translation comes in. You see, the TCP/IP address space is dwindling. There is not a lot of IP addresses left in the world. So in order to extend the life of the existing IP address pool, the folks that are responsible for TCP/IP addresses came up with this private idea and then implemented network address translation that basically translates private IP addresses to public ones. So let me give you an example. At Westminster College, we have a whole bunch of public IP addresses, but we've got thousands of private IP addresses that sit behind our firewall. We translate those out into just a few public IP addresses so that rather than having to use thousands of IP addresses that are public and that are becoming a scarce resource, we can use just a few addresses by doing this network address translation technique. There are some special addresses that you should understand. Now, I say here that there's a first range address and a last range address. The first range address often ends with .0. This is by far not always the case, but it is a case in a lot of times. This is the network address. So if you have 192.168.0.0, depending on what the subnet mask is, then that's the network address. The last range address, whatever the range happens to be, but they often end with .255, is what's called the broadcast address. If a resource is out trying to find something on the network, it will use the broadcast address to try to find that resource. It'll basically send out a network-wide broadcast saying, yo, you here? And if something responds, it's there. If it doesn't, it's not. Now that we've gone over how TCP/IP works, let's talk about how we make it work in Windows 7. This is where configuring TCP/IP settings comes into play. There are a couple of different ways you can manage TCP/IP settings in Windows 7. The most common way to manage these settings is through the graphical user interface, which is very good in Windows 7. However, you can also manage TCP/IP settings via what's called the network shell. That's a manual way that you can configure these settings using a command line interface in Windows 7. If you're going to create a whole bunch of machines and you want to script something, for example, that makes a change to the network configuration, you may not want to have to move manually to each machine and use the GUI to make that configuration. You may instead want to create a script that uses the network shell to make those changes for you across a wide number of machines. We're going to start by looking at how to manage TCP/IP settings via the graphical user interface. We'll take a look at how to configure a manual IP address and then how to configure the machine for DHCP, which is the GlobalMantic standard. Again, right now we're working on a Windows 7 machine in a lab, so let's take a look at what it looks like over on that machine. Here we are connected to the GM7095 machine again. And I'm going to go back to the Network and Sharing Center. Now I'm going to configure this unidentified public network, local area connection. As you can see, there is no internet connectivity here, and there's not going to be, but I want to show you how to change the IP address. And if we click Details, we're going to see that there's an auto configuration IPv4. The reason is because this network adapter can't find a DHCP server. So DHCP is enabled, but it can't find it, so it's using one of those automatically configured IPv4 addresses that we talked about earlier. And it's also using a link local IPv6 address that we talked about earlier as well. Now, using the GUI, we can manually assign an IP address to this machine by clicking the Properties button. And we're going to change only IPv4. We're not going to make any configuration changes to IPv6. So choose the IPv4 protocol and click the Properties button. Now, if I wanted to leave this machine as configured for DHCP, I'd simply say obtain an IP address automatically and leave it there. And that would basically tell this machine to go out to a DHCP server and get an address. However, I can actually configure an address manually if I want to. So if I want 172.16.0.2, these are all just addresses that I'm using as a sample right now, so don't use them for real. But this is a way that I could configure an IP address on this machine, on this adapter, that would then allow me to use this adapter on the network as long as it was configured to the right network. Now, one of the things you'll see is if I try to assign a default gateway to this adapter, it's going to tell me, hey, you've got 2 default gateways assigned. Well, you may say, no, I don't. There's only one. Well, there's actually two. And the reason for that is because I've got another adapter here. If I go to Properties, you'll see that I've got a default gateway already assigned on this machine. Generally speaking, machines should only have one default gateway, even if they have multiple network adapters. So you got to bear that in mind if you're configuring multiple network adapters in a single machine. Now, as you can see on this globalmantix.com address, I've manually assigned the address to be 192.168.7.10. I can change this. I'm going to leave the DNS server to be manually hard-coded as 192.168.7.1, but I can tell it to go ahead and get me an IP address automatically. It'll take it a second. And you'll actually see the network map change in the background while this takes place. And it's out identifying the network to see if it can do anything with it. Now, you'll notice that this lit back up, so that means that it was able to get an address. And now if I go to the GlobalMantix connection and click Details, you'll see that the IPv4 address that it got was 192.168.0.180. It got it via DHCP, and it also got the subnet mask, which is 255.255.0.0. Now, I left the DNS server hard-coded because of the way that the lab network at GlobalMantix is configured. It would have gotten the wrong DNS server had I allowed it to go out and get the DNS server via DHCP. So that was pretty painless. Basically, connecting to the network was very easy, and then switching back and forth between DHCP and a manual address is also very easy. And again, we'll take a look at the IPv4 side of things here. And you'll see that this is connected via DHCP, or as it was before, I can go back to a manual address. And once again, it'll take it just a second, but it will. It's much quicker when you assign a manual address because it doesn't have to go out and get a new address. IP addresses, you're generally going to see in dotted decimal notation. You saw before 192.168.0.0. That's called a dotted decimal notation, and that's what you're generally going to see. However, IP addresses are really just representations of binary numbers, which can then be converted into a decimal number. In fact, this IP address, 209.85.225.106, converts to this binary number, which converts to this decimal number. Now, I want to show you a neat little trick. You can browse to anything you want, 209.85.225.106. by just using the IP address. Now, you already know that going to www.google.com is going to take you to Google, but behind the scenes, that's what's happening. When you type www.google.com into your browser, your system goes out and looks that address up in what's called a DNS server, and we'll talk about these more in just a couple of minutes. It then looks up this IP address, and it actually visits the IP address, not the name, because the internet doesn't work on names, it works on numbers. I want to show you something else that's pretty cool. See this? 351.206.6410. I'm going to type that into the address bar. It, on the fly, converts the decimal number to an IP address. You can actually browse to a decimal number on the internet, and it will convert to the IP address that's associated with that number. I thought that was a pretty cool trick, so I wanted to just share that with you as a sort of an aside. Now, we talked before about the act of breaking a network down into smaller chunks. This is where this is called subnetting. This reduces broadcast traffic. Basically, if you start having, remember I mentioned that if a computer can't find another one, it will send out a broadcast and it'll try to find that computer. Well, imagine that happening with a network of tens of thousands of computers. You'd quickly saturate the network and you wouldn't be able to really get any work done. By breaking that network down into smaller pieces, you can reduce this broadcast traffic, and then the network uses other methods for computers to find each other. This also reduces what used to be a really problematic network problem, which is called collisions. The more traffic that's out of the network, the more likely it was that two network adapters would try to broadcast at the same time. That's a no-no, and that's called a collision when that takes place. Too many collisions and the network efficiency starts plummeting. So by subnetting your network, you can also reduce collisions. And subnetting also improves security if it's done right. Basically, if you have this one massive network, every user on that network can see every other resource. So if you want to be able to kind of close those domains down a little bit, you can subnet your network into smaller chunks so that only the users that should see resources can actually see those resources. There are two services that make TCP/IP really work the way it's supposed to. The first is called DHCP, or Dynamic Host Configuration Protocol. In the early days of the internet, network administrators had to run around and manually assign IP addresses to every computer on their network. As you can imagine, as networks were growing, this became hugely problematic. Administrators would have to try to keep track of what address they assigned to what resource, and if the network ever changed, it was a true nightmare to make those changes on every computer in the organization. Because of this, DHCP was born. This allows a central server to basically dole out IP addresses to computers in the network. So rather than some administrator having to do the sneaker walk around the organization and assign IP addresses, the DHCP server instead assigns those IP addresses. This really helps save a lot of time, and almost every organization, including GlobalMantic, uses DHCP at this point. Now, sometimes GlobalMantic desktop technicians might input a manual address when they're troubleshooting. This is also pretty common. So you want to make sure that you take, when you're troubleshooting, every possible contingency so that you know that you're working with a known set of assumptions. DHCP, if you're not sure it's 100% configured correctly, could be a problem. So in some cases, you'd want to be able to input a manual IP address just to make sure that things are happening the way you expect them to be happening. Organizations can also use DHCP to pass some other configuration information to clients. Beyond just the IP address, for example, DHCP will assign the subnet mask and the router address or the default gateway. When there is no DHCP server present and the machine is still connected to get an IP address via DHCP, automatic private IP addressing comes into play, or a PIPA. That is going to basically assign an automatic IP address to the machine and it's a known range. So if you have 10 computers and they all get an automatic address through automatic private IP addressing, they're all going to be able to talk to one another without an administrator having to take any manual action. DNS is the absolute most critical element of the internet. This provides a method to resolve friendly names into IP addresses. So www.google.com actually equals 209.85.225.10. How many of your users are going to be able to remember IP addresses for every site they visit? Now compare that to how many of your users will be able to remember the names of the site they visit. Humans are good with names. Humans are not good with numbers. Hence, DNS helps make it possible for users to be able to use the internet by providing that friendly name service. I wanted to give you a look at the GlobalMantic Southwest office so you can understand how TCP/IP really works in conjunction with DHCP. This is the GlobalMantic Southwest file server, and it's running both DHCP and DNS. The DHCP server has 5 addresses that are available. 2 have already been allocated, so that leaves 3 more available for allocation. The 2 addresses are 172.16.6.2. and that's been assigned to a desktop machine at the Southwest office. The 6.3 address has been assigned to a laptop that happens to be in the office, and it's connected via wireless network at GlobalMantic. 172.16.6.1 is a manually assigned address on the GlobalMantic file server, so it's not part of the DHCP allocation space. Likewise, 172.16.6.254, the address of the default gateway that connects the Southwest office out to the internet. Now the other side of this router is 192.168.10.5, and this is how the Southwest office gets out to the internet. So as you can see, there's a couple of machines that are getting their addresses via DHCP from the GMSW file server, and then this is the default gateway address for this network to get out to the internet. You should know that this is the 172.16.6.0 network with a subnet mask of 255.255.255.0. This means that the .0 is a network address, and the broadcast address for this network would be 172.16.6.255. Again, as a desktop administrator at Global Mantics, understanding the in-depth TCP/IP stuff isn't necessarily critical, but if you're going to do this for a long time, I do highly recommend that you use other train signal resources to get more information about TCP/IP and how it works. I've mentioned a couple of times now that the IPv4 address space, the commonly used TCP/IP out in the world today, is a scarce, dwindling resource. Enter IPv6. I don't know what happened to IPv5, so sorry, but IPv6 is the successor to IPv4, and organizations that manage the internet have been trying for a very long time to get IPv6 in more mainstream use. It hasn't happened yet. IPv4 is still by far the predominantly used version of TCP/IP out on the internet, but I would actually expect this to start changing over the next 3 or 4 years as the IPv4 address space really becomes even more limited than it already is today, and as more and more organizations get on the internet, and as more and more devices get on the internet. Think about the mobile phone explosion, iPads, iPhones, Android devices. All of these devices need IP addresses, and as time goes on, it's going to be a much more of a need for organizations to start moving to the new version of TCP/IP. So, what is so great about IPv6? Most importantly, the IPv4 address space is running out. There are only 2 to the 32 addresses that are available in IPv4, or about 4.2 billion addresses. That might sound like a lot, but when you start thinking about the fact that there are many more always-on devices, for example, home routers, home computers, servers running in people's homes, smart homes, iPhones, iPads, just you name it, it's out there. I mean, people's refrigerators and toasters are on the internet these days. These devices are always on. Well, hopefully your toaster's not always on, but your fridge probably is. And there are more and more internet users every day as well. China's exploding, and India's exploding. These people all need IP addresses. IPv6 goes to 2 to the 128 addresses. This is about a lot. I don't have an exact number. I could get it, but it's huge. Basically, with IPv6, the chances of running out of IP addresses are really not going to happen. So from a address consumption perspective, IPv6 is truly the future of the internet because you're just never going to run out of addresses. IPv6 also eliminates the need for a number of workarounds, including network address translation. So rather than having to use these private IP addresses that we have to use with IPv4, we can use IPv6 addresses directly and not worry about the complexity of things like network address translation. IPv6 also supports what's called stateless address configuration, although it can use DHCP v6 to provide even more capability. Stateless address configuration is just a way that IPv6 auto-configures itself to try to take some of the complexity out of configuring IPv6 away from administrators to make it easier for them to move to this newer protocol. As I mentioned, IPv6 is not yet in widespread use, although it's starting to grow a little bit. Some Windows 7 services will actually depend on IPv6, and as we hit those in this course, I'll explain to you exactly how to configure your IPv6 settings to use those new services. There are 4 different kinds of address types available in IPv6. There's link local, which is a local and automatically configured IPv6 address for networks that do not have a DHCP server. There's site local. These are those private non-routable IPv6 addresses. Remember, IPv4 has a bunch of private IP addresses as well. We mentioned those before. That's addresses like 192.168.0.1. Those are basically site local addresses that would be moved over to IPv6. There are then global addresses. Those are your everyday routable IPv6 addresses that are manually assigned or obtained via DHCP. Your link local addresses are sort of like those ones that are assigned through automatic IP addressing, or that APIPA thing that I mentioned before. And then you have special IPv6 addresses. An unspecified IPv6 address, or no address, is shortened to ::0. Its full address is 0:0:0. You can see it on the screen. There's a lot of zeros. A loopback address, remember in IPv4, a loopback address is 127.0.0.1, and that always points to the local machine. Well, IPv6 has the same thing, and it's : 1. That's, again, always the local machine. The reason you see these shortened notations here is because rather than having to type this whole string of things because it's all zeros, IPv6 does allow you to use shorthand notation, so you don't have to worry about remembering this whole thing and how many zeros are supposed to be there. You can actually type ping : 1, and you'll get a ping back from the local machine. That's ping is a tool that's used to test if a machine is up or not. And you can actually ping : 1 to see if your local loopback adapter is operating as expected. Let's do that. Ping : 1. And as you can see, it's getting a reply from : 1, which is the local machine, in less than 1 millisecond. I'm glad that it's so fast because if it was any slower than that, I'd be concerned about my machine. So managing these TCP/IP settings via the GUI is very easy. Managing via the command line is a little harder, but it's really not that horrible. If you take a look at the screen here, you'll see that there are some examples for how you can set an address in a DNS server for a local area connection. IPv4 has the syntax netsh interface IPv4, or just simply netsh interface IP. Now, the netsh stands for Network Shell and is a command line tool that's available in Windows 7. If you're going to configure IPv6, you would type netsh interface IPv6 in order to be able to make those configuration changes. The first command example sets an IP address for the adapter named local area connection statically to 172.16.6.2 with a gateway address of 172.16.6.254. The second command sets the DNS servers for that local area connection to 172.16.6.1. You can also go back over to DHCP using the netsh command by using netsh interface IP set address name local area connection source equals DHCP. Now you'll notice here that I have a command syntax that says netsh interface IP set address local area connection. Here I say netsh interface blah, 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 set address name equals local area connection. Name equals is not necessarily required for the netsh command. It just makes it a little easier to understand. So there's a lot of ways you can use the netsh command. It starts by saying I want to make an interface change to an IP interface. I want to set the address for local area connection statically to 172.16.6.2 with a gateway address of 172.16.6.254. Here you're saying I want to change the interface for IPv4 to set the address of the local area connection adapter to use DHCP. I'm going to go over to the Windows machine that we've been using in the example, and I'm going to set these addresses on that machine right now. Here we are back on GM7095. You have to use a command line, and you have to run that as administrator. It needs administrative access to really use all of the capabilities of the network shell. So I'm going to type netsh interface IP. I'll type IPv4 just because we can. Set address local area connection static 172.16.6.2 gateway equals 172.16.6.254. Now, did it actually do anything? Okay, I just typed that command. Did it happen to make any changes? Well, let's go look. Yeah, it did. So before, this was set to DHCP. I now overrode that and said I want to set it to 172.16.6.2 with an IP default gateway of 172.16.254. Let's now set the DNS servers. So this is going to set the DNS server IP address to 172.16.6.1. As you'll see, the system could not find that DNS server, so it says, it's not there, I really don't want to use it. It will still configure it, but it makes sure to tell you that it couldn't find the DNS server. This is a very, very good thing. So, the real DNS server that I'd like to use is actually 192.168.7.1. Now, you might wonder how this will work, but it'll do DNS lookups out over the right from the other network adapter, then the traffic will go out over this network adapter for traffic that needs to. You can use DNS servers from a different network. This time, it was very quick. If you remember before, it took it a second to come back. And if I go back now, you'll notice that the DNS server that it found was 192.168.7.1. You actually, it brings up an important point about DNS. DNS servers don't have to actually be on your network at all. You could have a DNS server that sits out at your ISP, and that's the only DNS server that you use other than the one you use for Active Directory. So, from that perspective, it doesn't really matter what you have for an address on your DNS server as long as it's valid. And as you can see, Windows will tell you if it can't find a valid DNS server. Now, if we want to set that address or that local area connection back to DHCP, there's a command for that. And to do that, we'll do netsh interface IP set address local area connection source equals DHCP. And when we go back to the details now, we'll see that this DHCP is enabled. It can't get an address because there's no DHCP server for this network adapter. But as soon as a DHCP server became available, it would get an address from that DHCP server. And we can do the same thing for the DNS servers. And if we go back into the details now, you'll see that there's no IPv4 DNS server because, it can't find the DHCP server, so there is no server. But if it could find a DHCP server, it would go and look at it here. Connecting to the network and connecting to an IP network are just two parts of the network equation. There's lots of other things that go into making a network work, and Global Mantis is experiencing a problem with some of its network equipment that's requiring desktop administrators to force what are called the network link speed and duplex values to a specific value because of some issues with their network equipment. The network speed is how fast the computer speaks on the network, and the duplex dictates in what directions the computer can talk, the network adapter can speak. Can the network adapter talk on the network while another computer is talking to it or not? Full duplex, it means that a computer has two-way simultaneous communication on the network. Half duplex means that the computer can either listen or speak but can't do both at the same time. Again, because of this network issue, Global Mantis wants to make sure you know how to set this value to a particular value so that you can get around this issue. I'm going to do this on the local recording machine because the virtual machines don't have the capability to configure the link speed in duplex. So we'll go to the Network and Sharing Center. I'll go to the local area connection 2, because that's the one I'm using, to the Properties page, and Configure. On the Advanced tab, you'll see that there's a speed and duplex option. Well, as you can see, there's 1 gigabit full duplex, and then there's a couple of 10 megabit and 100 megabit options. I'm going to choose the 1 gigabit full duplex option. You'll notice that if you're running a gigabit, there is no half duplex option because at that point you can't use half duplex. But for these other options, you could. So I'll change this to 1 gig full duplex and click OK. And you notice that it dropped off the network for a second and then came back. That was basically the network adapter beginning to understand its new role and making sure that it could still talk to the network equipment. If you choose the wrong link speed and the wrong duplex, your network will stop working. So be careful about that, or the machine will stop talking on the network. So make sure you know ahead of time what link speed and duplex value you should use before you make those kind of changes. Next, you should understand how you can configure device power settings to conserve power, particularly for mobile machines. Again, I'm going to do this on the local machine. So I'll go to the Network and Sharing Center, Wireless Network Connection, because I'm going to do this for the wireless adapter. Go to the Properties page, can click the Configure button, and then click Power Management. I can make sure the checkbox next to allow this computer to turn off this device to save power is enabled. That way, if the battery starts to get low, you can turn off the network adapter so that you can conserve some of that power and make your battery life last a bit longer. Now, you also want to make sure that this device gets turned off when the laptop is closed, for example, because you don't want the laptop to overheat, so you can turn off unnecessary devices when the lid is closed, and this can be one of them. Smaller GlobalMantic sites don't have their own network routers, so as part of the Windows 7 rollout, GlobalMantic wants to decide whether or not internet connection sharing could be of use for the organization. Now, these smaller offices are going to probably have to rely on internet connection sharing in order to keep costs down. And internet connection sharing is a service that allows a single computer with 2 network adapters to share its internet connection with other computers. Both Windows 7 and Windows Server 2008 R2 include ICS, as well as some older versions of Windows. The requirements for ICS are that the computer that intends to share its network connection has to have 2 network adapters. In a computer with only a single network adapter, you won't even be able to see the ICS option. In order to enable ICS, you have to have administrative rights on the computer, and you also have to enable some firewall exceptions to make internet connection sharing work. We're not going to do anything with the firewall in this particular lesson because we'll be talking about the firewall later in this course. I have disabled the Windows firewall on the machines we'll be using for these examples. There's going to be 2 machines that we go over and configure. We're going to configure one Windows 7 machine to be an ICS machine that's going to share its internet connection, and it has 2 network adapters. We then have another Windows 7 machine that's going to use this ICS to get out to the internet. Let's go try it. We're going to start out on the computer that does not yet have an internet connection, just so we can see what happens when we try to go out to the internet. I'm going to start Internet Explorer on this computer. And while we're waiting for that to start up, let's go over to the Network and Sharing Center, and you can see that there is no internet connection on this machine. And you can also see that it's taking quite some time for this error page to come up because it's not able to find an internet connection. Well, let's go over and enable internet connection services on another machine. Here we have the machine we've been working with up to this point in this lesson. I'm going to go to Local Area Connection 2 because that's the one that has the internet connection. I'll go to the Adapter Properties and go to the Sharing tab. And I'll click the checkbox next to allow other network users to connect through this computer's internet connection. Now, if I wanted to, I could choose which services these users can be able to access, but I'm going to skip that and just allow them to do internet. And then we'll click OK. And close. Now, what's actually happening behind the scenes is Windows is setting up a mini DHCP server that's going to assign addresses to the machines that are going to connect via ICS. So if I come back over here now, and I go to Network and Sharing, it's going to take it a minute, but eventually you're going to see this X go away and it's going to be able to get out to the internet. There we go. Now it's able to get out to the internet. And now when I go to trainsignal.com, I'm able to get out to the internet. I was able to do all that just by virtue of enabling internet connection sharing on GM7095, the other machine we've been using in this example. So as you can see, internet connection sharing can be a pretty good service. Those machines that are not able to get out to the internet can share the internet connection of another Windows 7 machine and go on their merry way. To get an overview of how internet connection sharing works, here's what we just looked at. Basically, the connection that was going out to the internet was this network adapter or local area connection 2 on that machine. We had ICS enabled, which allowed all the other machines on the network to get to this network adapter. So they were sort of isolated from the other one, and all of those machines were able to share this machine's internet connection to get out to the internet. One thing to keep in mind is you need to make sure that all of the clients are configured to use DHCP. If they're not, you're going to have a big problem because it's hard to always figure out what address range ICS will use. Finally, we want to discuss how to troubleshoot some network connectivity issues that may arise during your time as a Windows 7 desktop administrator, particularly as we start rolling out Windows 7 into the organization. Probably the three main standbys for any person that's using any way, shape, or form networks for any period of time are NetStat, Traceroute, and Ping. NetStat displays current network and TCP/IP connections to the machine and allows you to view Ethernet and IPv4 statistics and active connections. And we'll go over and look at that in just a minute. Traceroute allows you to see exactly what route your machine is taking to get to a particular resource. So you're able to view each hop of the network path between your local machine and a selected remote system. Ping, which actually stands for Packet Internetwork Groper, checks the status of a remote system. For example, do you think your mail server is down? You can ping that mail server and see if it gets if you get a response from that system. I'm going to move over to the Windows 7 machines and we're going to try all of this and see what we get. And I'm going to type the command netstat-e-s-p TCP. This will let me see all of my Ethernet TCP/IP statistics that are associated with my network adapter. So basically, this is how many bytes the machine has sent and received, how many packets. Now you see errors here as well, discards and errors. If these numbers go too high, there's a problem with the network adapter that you need to look into. You then get some general TCP statistics and a list of active connections from this machine. You can see that this machine, with an IP address of 192.168.0.180, is connected to GM-DC. That's because this is a member of the domain, and GM-DC is a domain controller. So you can actually get a list of all of the machines to which this machine happens to be connected. If I open up a browser and go to www.google.com, we may see that list change. Now the reason we see this rather than Google is because that's the router. The machine communicates with the router, and the router is actually handling the communication with the external entity. So that's what we're seeing right now. The next command is traceroute. Traceroute, if you just type traceroute, you get help, allows you to map the path to a particular resource. So if I do traceroute www.google.com, it's going to tell me exactly how it gets to a particular resource. So these are all of the various routers that this machine goes through to get to google.com. Now sometimes you might be surprised at just how many hops it takes to get to a particular resource. Now when it has to go through this process, it takes quite a bit longer. When you just go to www.google.com, this doesn't happen. There you go. So it took a little bit of time, but these are all of the various devices that this computer goes through in order to get to Google. Now, if you're having a problem on a network somewhere, especially internally, this will help you nail down exactly where the problem is taking place. Now, if I want to ping the local router to see if it's working, I can type ping 192.168.0.1, and I'll get a list of 4 responses telling me, hey, this is good. And it tells me how long each response takes and how many that I lost. There are some other issues that you can correct from the command line. You can fix a network issue using the ipconfig command, which is very common. The ipconfig release and renew allow you to release a DHCP address and put it back in the pool. And ipconfig/renew renews the address and pulls another DHCP address from the DHCP server. If you want to do this with an IPv6 address, the commands are ipconfig/release6 and /renew6. And those are pretty common commands. You're going to use ipconfig a lot as a desktop administrator. Often, DNS issues can have users really bashing their heads against the wall. You may end up with a situation where, for example, a bad address got put into the DNS cache for whatever reason. Maybe it was temporarily put on a DNS server incorrectly, but you may want to go ahead and flush the DNS server so that you can get rid of all those bad addresses. To do that, you again use the ipconfig command, but this time with a /flushdns command. If you want to refresh your DHCP lease and register DNS names, you can do ipconfig/registerdns. Or if you want to display the contents of your DNS cache to see where you've been, go to ipconfig/displaydns. Let's go try that. Here are all the sites we've been to recently with this machine. And you can see that there's quite a few because we did that trace route. That helps. But there's quite a few here. Now if I do ipconfig/flushdns, that flushes the DNS cache, and then there's nothing in there except what it was able to grab since the last time I flushed it. Now these machines are all very local machines, so that's why we're seeing them come back up immediately. But you're going to see that all those external addresses that we were looking at are pretty much gone. Before we move on, I want to show you from the command line that you can also troubleshoot your network. So go to Control Panel, Network Status, and we'll go to this one, the local area connection. You can click Diagnose, and if you're having a problem with your network adapter, clicking Diagnose will try to determine what the problem is. It will try to re-register your DHCP address along with a whole bunch of other things. So this time it couldn't find the problem, but you can click the Explore Additional Options and try to figure out exactly what's going on. And that way you can connect to Microsoft's forums, or you can ask a friend for help. There's a whole bunch of things you can do. But the Diagnose button is a way that you can take steps to try to solve problems from the GUI. We covered quite a bit in this lesson. We started with our scenario and moved on from there to managing network connections from a high level, basically getting the computer on the network. We then went over a relatively lengthy TCP/IP recap discussing IPv4 components and some components of IPv6, a protocol that's beginning to get traction in the world. You'll learn how to configure TCP/IP settings from the command line and the GUI in Windows 7. You then learn how to configure network adapters as a whole, and then how to share your network connection between multiple computers using internet connection sharing. At the end of the day, though, you have to understand how to fix problems as they arise, and you'll learn some basic troubleshooting techniques for networking in Windows 7. Thank you for listening, and I look forward to seeing you in the next lesson.